So there have been a ton of different robotics breakthroughs and releases and products in the last month. So let's take a look at some of the most important and some of the ones that you probably didn't miss. Starting with Sunday Robotics. Sunday Robotics is a US-based startup building a general-purpose home robot called MIMA. Now, this robot is focusing on real domestic chores like cleaning tables, loading dishwashers, folding laundry rather than humanoid locomotion. Now, the company describes itself as a helpful robotics company aiming to give people back its time by automating repetitive household tasks. Company led by Tony Zhao, it actually attracted a huge amount of venture funding from firms including Conviction and Benchmark. Now, I think one of the most interesting things about this humanoid robot, and remember, this is in 5 times speed, so whilst yes, this is impressive, the demo is sped up. And as I was saying, one of the most impressive things is that this kind of humanoid just completely ditches the bipedal motion. It opts for a wheelbase, which in many home environments is more than effective. And I guess they're opting to, focus their time and attention to the torso, which is where I guess you could say the value is provided. I don't think most humans would care if their humanoid can walk up or down stairs, considering that most places don't have stairs. But if you are going to be affording this robot, I'm guessing that you probably will have stairs, considering the house it might be a bit more expensive. I know that is quite the speculation, but I think this goes to show that different approaches to the same problem via different companies can lead to different outcomes. Now, this tall wheeled domestic robot has a really cool vertical lift that you can see, so it's able to go all the way up and all the way down. It's able to shift that base vertically, move forwards and backwards, is really effective for navigating the complete home. You can see that they've got their Act 1, which has 0-shot generalization, meaning ideally it can just look at a task and then complete it. Now, what's really interesting is that this robot can apparently perform long horizon tasks such as clearing a messy dinner table, sorting items, loading a dishwasher, and handling fragile glassware, and folding piles of socks, all with smooth autonomous motions. Now, the training approach, which is the glove and Act 1, Sunday actually avoids the traditional teleoperation and instead ships a skill capture glove to memory developers, which are users who perform the chores in their own homes while the system records the motion and the force data. And then this data feeds the Sunday Act 1 Robot Foundation model, which they claim is trained on 0 robot teleop data and can generalize to new homes and layouts for complex multi-step tasks. Now, the current status and availability of these robots, maybe you want one, is that Sunday reports having shipped over 2,000 gloves and collecting data from around 500 homes to expand Memo's skill library. The company has announced an invite-only free beta program targeting deployment of Memo into about 50 households in 2026, with broader consumer availability likely following that initial trial phase. Now, how does this compare to the landscape? Well, unlike bipedal efforts like Tesla, Optimus, or Figure's humanoid, Sunday prioritizes a wheeled semi-humanoid form factor tailored to kitchens and living spaces. Now, this trading stair climb, they essentially trade the stair climbing ability for stability and runtime. Next, we have Sourccey. Now, Sourccey is an open source home robot, like a personal home robot designed to assist with household chores while serving as an educational tool for learning robotics and AI. Now, this was launched as a customizable, user-trainable companion, which allows its users to teach it tasks through demonstration, adapting to specific home environments over time. It's built to be approachable and friendly, bringing a sense of joy to daily routines rather than just functionality. Now, this robot features some key things. It's got trainable chores, so users can actually demonstrate tasks like cleaning, organizing, or other household activities. And Sourccey uses AI to learn and improve more and more training sessions. leveraging compatibility with the Robot framework, an open source robotics library. Now, what's cool about this robot, unlike the previous one, is that it's got a completely open source design. And this means you have full access to the source code, the APIs, and documentation. And this is all provided via the GitHub, enabling customization, extensions, and community-driven improvements. Now, this is ideal for beginners in robotics, programming, AI, as it doubles as a hands-on learning platform without requiring advanced technical skills. Now, what's really cool about this is that it's actually available for the official site, it's called Sourccey.com. And this robot is actually standing out in the growing field of domestic AI assistants like Neo or MIMO by emphasizing on the open source accessibility and learning by doing, making it particularly appealing for hobbyists, educators, and tech enthusiasts. So, of course, if you're interested in building or modifying on it, the GitHub repo is a great place. The GitHub repo is a great starting place. Now, I think this is going to be super interesting for those of you who want to focus on your own personal style of robotics, because there are many different humanoid robots that are out there, but one of the key barriers to entry is very high costs. The Unitree G1, I believe, costs around $16,000 to $20,000, which is just simply not feasible for the average person. And I do believe that the Neo robot costs once again around $20,000 or $500 a month for a home robot. So overall, this open source framework, I'm not entirely sure how much this robot costs. In fact, it literally just came up. It starts at around $1,500. It's a lot cheaper. It may not be the most aesthetic, but I guess you could say this is more like a developer platform where you can use this to learn quite a lot about robotics and use it in your home, provided you do the learning via demonstrations. Now, there was also this, which I found super cool. There was the sanitation robot competition in Shenzhen. It's basically a real world robot contest where dozens of companies deploy autonomous cleaning robots on actual city streets and public spaces to demonstrate and benchmark their capabilities for urban sanitation work. It's essentially part of a tech showcase, which is aimed at accelerating the rollout of AI sanitation fleets for Chinese cities. So the competition is formally known as the 2025 Shenzhen International AI Sanitation Robot Competition and related exhibition segments under Nanny Robot. It is organized by the Shenzhen Municipal Government and Longyang District, together with national media and industry associations as flagship AI and sanitation's initiative. Now, reports describe more than 40 sanitation robot enterprises participating, with over 200 autonomous robots from 40 plus companies in some segments, competing or demoing in over 100 individual sessions. Urban management departments from over 200 cities and more than 500 enterprises were invited as observers and potential buyers. Now, robots are evaluated in real scenario tracks such as parks, squares, sidewalks, and cycle lanes and service/auxiliary roads, rather than in those pristine lab environments. And the tasks include sweeping, vacuuming, spraying, trash pickup, bin handling, climbing, and navigating complex terrain while avoiding pedestrians and traffic. Now, a big emphasis is on fleet-level autonomy. Many robots run fully autonomous navigation on open sidewalks and roads, coordinated over 5G and IoT infrastructure. Some segments highlight integration with Open Harmony and mRobot's operating system and smart city systems to show end-to-end urban cleaning workflows, meaning complete autonomy of cleaning. Now, this competition is explicitly tied to procurement and standard setting, with draft national technical requirements for AI cleaning robots presented and on-site matchmaking for government orders. Shenzhen's Longyang district has committed large volumes of future robot procurement and pitches this as part of building a 100 billion yuan plus intelligent sanitation market and full robotic supply chain. Now, if we're talking about China, we can talk about the Chinese startup Mindon, which actually trained a Unitree G1 to do house chores. Interestingly, there was no speed up and no teleoperation. This is a small new robotics company coming out of Shenzhen, and There wasn't any information prior to this. They just came out of the woodwork and said, look, we're going to drop this robot demo. Now, this one shocked everyone because the robot moves fast, fluidly, and naturally, and it's way more lively than what we normally see from big companies like Figure or even Tesla. Look at it. It's using its knees to get on top of the bed and iron out some creases. Incredible. Now, the robots in the demo, why this is so impressive is because it opens blinds quickly, fast, contract-rich motion. The curtains are soft and hard to simulate. So the smoothness, when we think about it, that's rather impressive. Being able to water plants while carrying a heavy watering can, and balancing while holding weight, and stepping onto a platform while reaching even more plants is uneven terrain. This is a hard robotics problem. I don't think people are understanding the scale of just how hard that problem is for robots. These actions are very, very human-like. I mean, carrying a gift box to kids, this shows good whole body control even whilst you have an object in your hand. And this is similar to recent research papers such as LEMMiNO. And once again, crawling onto a bed and ironing it is such a weird task, but it's technically impressive. Climbing and crawling motions are usually hard. They require advanced retargeting techniques such as omni retarget. And, cleaning a room while kids plays, toys are everywhere, proving that this is not just entirely scripted. It means that the robot somehow is seeing objects and reacting. Now, it's incredible because someone wrote a Twitter thread on how they probably did this. They said that the behaviors of this robot likely came from policies trained on human videos or mocap and not teleop, and modern imitation learning techniques such as LEMMiNO, HDMI or omni retarget, and possibly UMI for grasping. And this is actually aligned with the latest big research breakthroughs in robotics. And clearly, Mindon has stitched all of these, recent breakthroughs together and performed this demo. Now, some people were even speculating that this demo is fake. Now, everything in this demo is actually achievable with today's methods. The motions look exactly like the state-of-the-art academic demos, just executed much better. Now, this is a completely huge deal. This is just a brand new startup founded in May 2025 by ex-Tencent researchers, and they're already showing fast, useful actions, and these aren't slow stage demos, meaning that the race for embodied AI is wide open. If a relatively small company can suddenly leap forward, it now means that there are new players emerging, meaning that Mindon is one of those companies to watch. It'll be certainly very interesting to see where things go moving forward, because this is one of the most impressive recent demos I've seen of the Unitree G1 in action, doing multiple different tasks with human-like motion, completely smooth, fluid motion, and no speed up and no teleoperation. Very, very impressive stuff. Even with teleoperation, some of these tasks I believe would be hard. So for this to be completely done, not completely done, but done already in this impressive demo, it's super, super impressive. Next, we had a UK-based firm, Humanoid, unveiling a legged version of their HMND01 Alpha. There is a European company releasing their new humanoid, and this is a UK-based startup unveiling Alpha. Now, this is a biped that has mastered stable locomotion in only 48 hours after assembly. This is something that normally takes weeks or months. And the shortcut, if you're wondering, the humanoid ran 19 months of locomotion training in simulation, using ultra-precise virtual replicas, and then they transferred the policy to the physical robot. Now, Alpha can walk in curved paths, sidestep, hop, recover from pushes, run, and lift up to 15 kg. The company is following a familiar roadmap: industry first, then they're going into services, and then they're going to be moving into the home. Now, they've already tested early prototypes with, bin picking with this company called Schaeffler, and there are future deployments possibly planned for hospitality, healthcare, and elderly care. And by 2031, HMND, or the company called Humanoid, wants Alpha-class robots doing routine household tasks and filling labor gaps in sectors where staffing is hard work and physically punishing. So this is probably one of the first times I've seen a UK-based company, other than, Google DeepMind, focusing purely on robotics. Super interesting. Then we had Unitree deciding to show off their H2 fighting robots. Despite saying that it's not designed for combat, it was showing robots that were doing exactly that. It's showing the, G1 fighting another human, and then another H2. So the H2 is the bigger one on the left, and the G1 is the one on the right with the broken arm. So you can see here that the H2 is being pushed around by a human. It's kicking, it's, trying to move. And I think 2 years ago, this would have probably been CGI, but the fact that we now accept this as normality is pretty interesting, because seeing these robots move in such a human-like way has stark implications for the future. What happens when these robots get incredibly good and even better than humans at these fluid-like motions? Are we going to see, robot fighting championships? Are we going to see real steel really be there? If you know, you know. But it's going to be super interesting to see the future of how robots, navigate these truly dynamic environments. Sometimes these robots are just kicking out of pure, instructions. There are controllers behind. But what happens when you have a robot that's able to completely autonomously engage in its environment, move forward and backwards, and judge an enemy and attack and, box in a way that's really human-like? I think those demos are going to be completely surprising. Now, if we're talking less about fighting robots and more about movement, then we have to talk about the Tesla bot Optimus Generation 3 performing a new personal record at 8.5 miles an hour. This demonstration doesn't seem that impressive if you haven't been paying attention to the area of robotics. And the reason is that it just seems like a robot running across the screen, until you realize that it's not CGI. This is a full humanoid. And I would argue one of the first times we're seeing a humanoid that looks incredibly realistic in full autonomy. Now, previously, we'd seen demos of the Tesla bot doing different things at, Elon's events, where they go and showcase the full entire roadmap of what Tesla has to offer. But often, most people didn't realize that those were completely fully teleoperated, meaning that the demonstrations weren't as impressive as they seemed. But now we have something rather interesting. We're seeing the Gen 3 actually move autonomously across a plane, and it looks exactly like a human would if they're jogging. I would argue it would even look more graceful than many humans jogging. So this is really surprising, because in order to get a humanoid robot to jog as fluently as it is there, you have to succeed on a remarkable number of individual components that all have to work together well. You have to ensure that the, humanoid can support the weight as it flies through the air, though it doesn't seem like it's flying. Certain points where, maybe for like 0.1 or 0.2 seconds, it is literally airborne, and it's able to do that at a stable weight. Now, this isn't to say that maybe they didn't crash, or, the robot behind the scenes. I don't know how replicable this is, but it's pretty clear that we crossed the threshold for robots that look, incredibly human. And for those of you who don't believe me, what's so interesting about this is that when we got the Tesla Optimus Gen 3 video, we actually got another demonstration of the Figure 3 robot doing the exact same thing. And I would argue that this robot looks really impressive, considering the fact that it wasn't like this was a scheduled release. This was just a response literally to the Tesla tweet. Someone literally called out Brett Adcock and says, look, this is your time to shine. And he then tweeted this. So it's quite likely that Figure 3 are probably much more ahead than we even do think, because this robot demo wasn't even scheduled. It was only shown to us because people had the perception that Tesla had moved forward and stolen the limelight. But Figure 3 were like, look guys, we're still on the same pace. We're just moving, and keeping our heads down. Now, I would argue that this one looks even more impressive. There's just something a little bit more fluid about this one, just the way it moves forward and then it goes backwards, whereas the Tesla one is just, completely running off screen. Here we can see the robot, jog first, stop, perform a 360 turn around, and then do it in the exact same way, exactly like a human would. I mean, it's uncanny, with the subtleness to how the robots move like a human. It really just freaks me out to the point where I almost believe that there's like some human teleop or some human somehow, somewhere inside that robot machine. But of course, as you know, this is not the case. This is a fully autonomous robot that is able to do this. Now, I think once again, I need to show you guys where the previous generation of models were. Take a look at figure 2. This was the robot, okay, just a few months ago. Figure 2, the last generation of robots from the exact same company. Now, what you have to understand here is that this, in and of itself, is still remarkably impressive. You've got a robot that is able to walk up and down an uneven terrain which it wasn't trained on, meaning that the robot is likely just, analyzing and, completely doing this autonomously, which means that whilst most people think that, okay, the robot is looking like quote unquote Joe Biden, as many people have memed around, this is remarkably hard for robotics. So this is uneven terrain, but this is of course in a pristine lab condition. Now, by no means am I, removing the capabilities of these robots. I'm saying that this is, much more impressive than you do think, considering what we had just 2 years ago. Which, if we're looking at things, let's say we decide to look at them exponentially, you can only imagine just how quickly robotics are moving. Remember, it was only, I think, 6 to 8 months ago that we saw Boston Dynamics perform similar leaps in terms of the agility with their Spot robot, or their, I can't remember honestly what the name of that robot is called, but it was only when we saw that one did we realize what the true potential was. And 6 to 8 months later, we have other humanoid robots catching up. I do wonder if Boston Dynamics are going to get leapfrogged, although I do highly doubt that, as they are quite the innovators in the space. But this makes me extremely intrigued for what the future holds once these robots are deployed at scale and they're able to do a variety of different things. Now, we also had a new demonstration of the Unitree G1 from MagicLab, and this is the MagicLab Z1. And I mean, this is particularly incredible. Robots, I don't know about you, but I don't remember them being able to flip like this, let alone humans that can flip like this with such agility and dexterity. And so we have the MagicLab Z1, often branded as the MagicBot Z1. This is a small, highly agility humanoid robot from a Chinese company called MagicLab. Now, this is designed as a general purpose mini biped for research, education, service, and companionship scenarios. Now, this is roughly around 1.36 to 1.4 meters tall and around 40 kilograms, and it's optimized for very dynamic movement, fall recovery, and expressive interaction rather than heavy industrial payloads. Now, the core concept here is that the Z1 is built as a compact bipedal humanoid with 24 core degrees of freedom, expandable to around 49 to 50 degrees of freedom using optional modules and dexterous hands. Its main pitch is agile and explosive, motion in human spaces such as fast walking and running, and acrobatic like bending, combined with relatively low cost to compared full humanoid competitors. Now, the robot uses MagicLab's self-developed high-performance smart joint modules with a joint torque on key axes exceeding about 130 Newton meters, allowing it to withstand hard shoves, repeatedly fall and stand, perform large range poses, and it's, able to jog around 2.5 to 3 meters per second. And it's able to step over obstacles about 15 centimeters, targeting uneven floors, grass, gravel, and small steps. And it carries a 360-degree perception stack, including stereo, depth cameras, 3D, LiDAR, and fisheye or binocular vision, plus MagicLab's Atom positioning and navigation system for autonomous navigation in cluttered spaces. Now, public materials mention use of embedded compute, for example, Jetson-class modules for AI navigation and interaction. But most of the marketing that I found focuses on the joint tech and sensor fusion rather than specific CPU or GPU SKUs. And the base robot can actually be fitted with the Magic Hand SO1, which is an 11-degree of field, 5-finger dexterous hand that lets each hand grasp delicate objects or lift a few kilograms, around 3 to 5 kilograms give or take. And the Z1 supports voice interaction, gestures, and anthropomorphic emotional expression, making it suitable for roles like exhibition, guides, demo platforms, or whole educational companions. Now, we also had, I couldn't do the video without this one, the Xpang Iron. This is the full-size humanoid robot developed by the Chinese EV and tech company Xpeng. This is designed to operate in human environments such as factories, shops, offices, and public venues. And this is positioned as a human-like AI, physical AI. And this is the platform that Xpeng manages, well, not manages, but hopes to mass produce around 2026 for commercial deployment. Now, they've built this as a general purpose human-shaped worker that can walk, manipulate objects, and interact with people using onboard AI, rather than being a fixed industrial arm or a warehouse bot. The Xpeng is basically tying it to the same AI stack as its autonomous cars and the robotaxis. So the perception, the planning, and the control share a common architecture. Now, the robot is roughly human-sized, incredibly human-looking, and it's got dozens of joints across the body, highly articulated hands with around 22 degrees of freedom for fine manipulation. And it uses, incredibly, a bionic bone muscle skin structure with a flexible spine and soft synthetic outer skin to make the motion more human-like and, safer to come in contact with people. Now, it's powered by Xpeng's in-house Turing AI chips, but I actually want to show you guys that flexible spine, soft synthetic outer skin that I was talking about. Take a look at this. So you can see right here, you've got them cutting open the robot's spine and the skin just to show you guys the details. In fact, they didn't do this to show you guys the details. They cut this open because individuals, upon seeing the Xpeng demo, did not or could not believe what they were seeing was an actual robot. They believed what they were seeing were a, human in a suit that was acting as the demo. In all fairness, we've done that in the past. In the Tesla demos, in 2021 or 2022, it was literally a person in a suit. But now we can see that this is not the case. From ideation to reality, with Xpeng, we now have the complete full roadmap of what exactly happened. We've gone from people in suits to robots that actually look like humans in suits. And honestly, this is one of those moments where we start to realize the moment we'd crossed into the uncanny valley. Now, they're not the only company that's in the uncanny valley. Take a look at the Engine T800. This is a full-sized humanoid robot by a company called Engine AI. This is the robot that's built for high agility, high torque, and quote-unquote combat capable. And it's, also for industrial tasks. Now, this is roughly human-side, and it uses aviation-grade metal structures, and it's marketed as a powerful dynamic platform for logistics, service, and potentially security or competition scenarios rather than just a demo. Now, the T800 is designed as a general purpose humanoid that can perform practical and, execute very dynamic motions like kicks and spins and rapid movement. And, this humanoid is focused on, strength, endurance, and multi-role deployment in real environments. Now, you've also got the size, mechanics, and mobility. Recent specs describe the T800 at about 1.7 to 1.75 meters tall, around 60 to 75 kilograms depending on the configurations, with around 29 body degrees of freedom, plus dexterous hands, bringing the total into around the low 40 degree of freedom range. Now, joints can deliver up to 450 newton meters of torque, enabling sprints of around 3 meters per second, and highly explosive motions you can see right here, such as the flying kicks, the punches, the capoeira style moves, backed by 2 to 4 hours of runtime from a modular solid state battery. Now, the robot uses an embedded compute stack that in higher end variations can include NVIDIA Orin Jetson Thor class modules, providing on the order 2,000 TOPS for embodied AI workloads. Its perception suite typically combines 360-degree LiDAR with depth/RGB cameras to support the navigation, obstacle avoidance, and high-speed motion in cluttered spaces. Now, the T800 can also be equipped with Engine AI's own multi-sensor dexterous hands, usually quoted at around 7 degrees of freedom per hand, with tactile sensing and per arm payloads in the 5 to 15 kilogram range depending on the source. This lets it handle both core strength tasks and finer manipulation like sorting or precise placement. Now, Engine AI, it markets itself for industrial logistics work, for moving goods and service hospitality roles, and as it says, combat. So it's going to be interesting to see if a robot is going to be fly kicking people in the future. Honestly, I really hope we're not moving towards a dystopian future, maybe just a robot fighting competition. I really do hope that is the extent of things. But I gotta say, it looks super cool. And these robotic demos just look more and more human as we get day by day. I mean, I think it's one thing to see these robots on YouTube, but I haven't actually seen any of these robots in person. And I think maybe my mindset might shift once I do see these robots running around and doing a variety of human level tasks. So should be super interesting to see what that looks like in the near future. We also had the flagship humanoid LimX OOLI, also referred to as the LimX CL1 in earlier models, or Ali in some demos. This is a full modular size humanoid with 31 active degrees of freedom, supporting dynamic stair climbing, heavy payload transport, and complex navigation in warehouses or homes. And we can see just how stable this robot is as it navigates some really rough terrain walking. I mean, it trips and recovers completely. And I can't say I often do this myself. I'm not saying I fall over, guys. I'm just saying that I've seen some very ungraceful falls in my time. So these robots are becoming extremely prudent at how they walk and how they carry themselves. And we can see this evolving in one-time speed. It's important to note that that demo right there is deliberately noisy in terms of the environment, because that is the real world. You want to test the world in unsexy environments so you can really see how well it performs on the most difficult, areas, because a real world lab where everything's perfect and pristine and you've got the, yellow box that it's supposed to walk around, that isn't how the real world works. Sometimes there might be a slew of different materials like you see in this video, and it's important that the robot is able to navigate that environment successfully without additional help, and to be able to do it completely autonomously. And that's what we see here. So it's really impressive that we're seeing so many companies solve these issues that once plagued normal robotics. And another humanoid robotic startup that exists is Norway-based Physical Robotics. This company is finally out of stealth. This company was founded by Fyong Nguyen, a co-founder of Halodi Robotics, which is now rebranded as 1X Technologies, which is of course the company that founded the Neo robot. Now, he was Chief Science Officer at Halodi or 1X Technologies for 8 years, leading the development of the Eve robot. And he's started this new company, and their mission is to create a generation of robots that live in harmony with humans in the physical world, enhancing the quality of human life. And last week, the company announced the closing round of $4 million. We've also got this, which is super interesting. So Kyber Labs, often referred to in coverage as Kyber Lab Robotics, is a Brooklyn-based, New York-based robotics startup building AI native manipulation platforms with a particular focus on highly dexterous hands and artificial muscle actuators. Now, this company was actually founded in 2022, and it was founded by a small team including a former SpaceX MagicLab Labs engineer and an industrial designer from electric motorcycle startup Tarform. And it positions itself squarely in the embodied AI manipulation space rather than classic humanoid walking robots. Now, they're basically building bimanual robotic manipulation platforms, which are 2 arms and hands designed from the ground up for AI-based control and reinforcement style training. Now, their core hardware uses low-cost artificial muscle fiber actuators that mimic human muscle, giving the system pliant backdrivable motion that can handle delicate tasks that you're seeing, like threading or nut tuning, and high-impact events like being hit with a tool without fragile gearboxes. Now, their focus is on robotic hands. Much of the public demos that we've seen so far are of a high speed, real-time, and feel contact through motor currents rather than relying on fingertip tactile sensors. And the hand emphasizes backdrivability and torque transparency so that external forces move fingers naturally, making it better suited for learning-based control and safe physical interaction with objects and people. Now, They explicitly are targeting high mix, low volume manufacturing and assembly work that is hard to automate with traditional fixed jigs and rigid industrial arms. The idea for this company is to provide a general purpose AI-ready manipulation platform that can be dropped into real factories and warehouses to handle varied tasks in unstructured environments. Now, they see themselves as building robots designed for AI, arguing that current industrial robots are too stiff and too brittle for large-scale reinforcement learning and AI-enabled training loops. Rather than prioritizing walking humanoids, they are emphasizing the economic value of humanoids is mostly in the hands, and their roadmap centers on dual-arm, human-level dexterity with strong integration of learning-based control. Now, we also have Eggy, which is a new competitor in the humanoid robot race. A new startup called Tangible has come out of stealth with Eggy, a wheeled humanoid robot launching the same day the industry was actually reacting to the Sunday robots that you saw first. Now, Eggy is a sleek, friendly-looking wheeled humanoid robot designed for everyday home use. This demo video shows Eggy wiping a kitchen counter, signaling real-world manipulation ability. Now, this was built by a team led by MIT PhDs focused on robotics and AI. Now, the big difference is that they're focused on 5-fingered hands, unlike Sunday robotics. Now, once again, this Eggy robot is actually a wheeled robot, so a wheeled humanoid, and I think this might be an interesting, thing moving forward. Now, I think the difference the difference between Eggy and the Sunday robot, because a lot of people were comparing these two on Twitter, is that there's 5-fingered hands. So now the big differentiator that we can see between these two robots is that one has 5 fingers and one has a very simple hand. So people were debating, the differences on Twitter, but their philosophy, Eggy's philosophy, is a full stack touch. So Tangible is vertically integrating everything, the hardware, the software, the control, the data, and they're focusing on dexterity, compliance, whole body control. And their goal is basically robots that thrive in, unpredictable, cluttered home environments, not just structured labs. So they basically say that robots aren't just embodied AGI, they are the truest forms of AGI. What is AGI without touch? So, they collected data, engineers were wearing sensor heavy exoskeletons to record the tactile data, like how hard to press, how hard to grip fragile versus rigid objects. And this is aimed at capturing the subtle, physical intelligence needed for home tasks. So it basically joins the entire field of rapidly growing home robotics field. I think there's, 2 fields in robotics, the ones that are, going to be in factories and the ones that are going to be in our homes, personal for us. And that's where, Tangible is bringing this robot to. Now, there's also Agile Robotics. This is a robot from Germany, and they are stepping into the humanoid big leagues. So Agile Robots is a Munich-based robotics unicorn with deep German aerospace center roots, and it has officially entered the humanoid race with Agile 1, a bipedal, factory-focused humanoid built for real industry work, not demos. This thing is 174 centimeters tall, 69 kilograms, and the payload is 20 kg. This is designed specifically for warehouses and factories, navigating narrow aisles and working directly alongside human staff. The big selling point is they have the world's most dexterous hands. They are going all in on dexterity, sensors in every joint, fingertip force torque sensing, aiming at delicate assembly tasks that normal robots struggle with. And this places Agile Robots right in the humanoid hand arms race. So other companies are taking different paths. Tesla is 50 actuator, superhuman, precision, hands. Boston Dynamics is the simple 3-fingered gripper. If you've ever seen it, it's pretty cool. And then, this company is taking a completely different approach. Now, super interesting stuff, because we have other things such as them saying that they're only focusing on premium, physical AI, the intelligence layer. Agile is, trained on one of Europe's largest industrial data sets, and it's actually part of a broader ecosystem called Agile Core, integrating humanoids, robotic arms, autonomous mobile robots, and the goal here is an entire intelligent production system, not just one robot. So they're, DLR legacy. And the key thing here is that Agile will be, fully manufactured in Bavaria starting in early 2026. tight quality control, less outsourcing than competitors. And Germany is quietly becoming a powerhouse in cognitive robotics, and they're entering a market where neurorobotics already exists. So it's going to be interesting to have some very interesting competition. Now, lastly, we do have Pi AI, which is incredible. This demo is just insane. Please watch this.
Hi, I'm Laura. I'm a researcher at Pi. We wanted to see whether we could get a robot to actually help us operate an in-office coffee bar. In order to start this experiment, we went to a local coffee shop and worked with professional baristas in order to understand what the robot could do alongside a person to be helpful. One of the aspects that makes this really difficult from the low-level control side is tool use with a lot of precision. So picking up that portafilter, inserting it, aligning it, and locking it in. In addition to that is the liquid handling for this task. So the robot needs to be able to pour without spilling, and that requires a really smooth and steady hand. Now the robot can make all sorts of drinks like Americanos, lattes, double shot espressos, and it's keeping the office all very caffeinated.
Here's your latte.
Thank you.
To understand how to make our models truly useful, we partnered with Dandelion Chocolate to explore automating some of the repetitive tasks in production. So the reason we chose box building is it's actually not just something that's valuable to Dandelion, but it's a really great testbed for our method. In the past, automating a task like this would require specialized, expensive machinery that often doesn't make economic sense. What makes box building challenging is that for it to be useful, it needs to run for many hours without human intervention. Any mistake along the way could mess up the box, mess up the label, and send the robot right back to the start. By training merely on teleoperated demonstrations, we tend to produce policies that fail fast and struggle to recover. By learning from experience and guided corrections, we are able to teach the policy how to recover from difficult situations and avoid taking risky actions that might increase the chance of failure.
Hey, what's up? To make robots useful in the real world, they need to be able to go outside of the lab. People need to be able to bring them into their homes and have them actually do useful things. And in this experiment, we wanted to test exactly that. Take it into a home it's never been in before, give it clothing items it's never seen before, and see if it can fold them effectively. A lot of our prior models learn from supervised data or demonstration data. With our new approach, we wanted to see if we could have a model that could learn from its own experience. And doing this allows it to see its own mistakes and learn how to correct them. And we found that for this laundry task, these models that are trained with their own experience tend to be more decisive and have more successful outcomes as a result. We're super excited about this experiment that we ran. We found that we could just bring a robot into a home it hasn't been before, clamp it onto the table, and it did a very reasonable job of folding a lot of different unseen laundry items. Things are still far from perfect, but we're really optimistic about the progress we've made so far.
And then something I found that was really funny was the world's first robot dunk, not dunk, but someone blocking the shot of a robot. It was crazy. It was just crazy. There's no other way to describe this. So I don't know how he taught a robot to, use a basketball and dunk. If you go onto his page, it's super interesting. All of the simulations he's been doing. He's actually been working on this for quite some time. And then he actually blocks a robot from getting a free throw. So I don't know. This is just pretty funny. So let me know if you guys enjoyed this video. I'll see you in the next one.